Hi, welcome to everyone's favourite segment, Mailbag. Let's get into it. If you want to send something in, anyone, individuals or companies or whatever, you can send it into Mailbag. Got to have Mailbag on it. PO Box 7949, Borkham Hills. It's actually Norwest, but Borkham Hills will get here too. New South Wales 2153, Australia, not Austria. And this one is hilariously from Tennismatic. And if you saw my recent repair video on Mrs. EEVblog's Tennismatic remote control unit, which was a rather interesting failure, they're in Wetherill Park here in just practically a stone's throw from here. That's the company that makes that automated tennis serving machine that Mrs. EEVblog loves, because Mrs. EEVblog is a competition tennis player and she loves her new tennis, well, we got secondhand, Tennismatic machine. So let's have a look. What is this? We've got, springs, update. Ta-da! Look at this. Winner, winner, chicken dinner. They actually sent in a brand new membrane keypad, 3M, genuine 3M 467 adhesive. Thank you very much. None of that cheap rubbish. Hang on, let me have a smell. Yep, that's 3M adhesive, all right, fantastic. Thank you very much for sending in that. They must have saw my video somehow, and shows up on the search or whatever, I guess. And this looks like a sort of, I know there's like an upgrade kit for their Tennismatic machines that has some sort of, I don't know, it's got all these different functions. Like it's got feed and sweep rate and, elevation and all that sort of jazz. So anyway, it's been working fine, by the way, the repair on that unit. Oh, well, there you go. It's from Vincent, and Vincent is actually a viewer of the channel. I was pleasantly surprised to see your repair on my control and did a great job on repair. Thank you very much. Hopefully the repair holds up. It has been, but just in case it doesn't, and, well, yeah, I didn't expect it to last, forever. I sent a replacement membrane along with some hopper springs and cover screw in case the previous owner of the machine lost them. Thank you very much. I think we do actually have, I haven't used it myself, but we do actually have, I think, something like this inside, but I'm not sure, but it's good to have spares. Excellent. We changed the design of the membrane slightly so the window for the lead may not align with the hole, so you might need a larger drill. No worries. When you remove the membrane, there may be some adhesive left on the surface. Yep, use your thumb to rub it off. Yep, and get some metho to get rid of that. Have any issues? Please do not hesitate to contact us. Thank you very much, Vincent Pham from Tektron Electronics. Tennismatic. That's great. I don't know. Leave it in the comments down below. Should I install this straight away, or should I see how long my little bodge silver ink repair does? That's great. Thank you, Vincent. What are the odds of that I just repair a random company's product and they're viewers of the channel? It's actually not the first time. It's more frequent than you think. My videos tend to get around. We don't get many old school letters like this, so thank you very much. EEVblog, they almost forgot to put Mailbag on it. You have to put Mailbag, otherwise I don't know whether it's something I've damn well ordered and forgotten about, or whether or not it's supposed to go on the Mailbag shelf. Again, Borkham Hills, technically it is Norwest, because it was Borkham Hills, and then Norwest got so popular, Norwest Business Park here got so popular that it's now an official suburb, but it is actually the same postcode, so it'll still get here. No worries. And it's Australia, not Austria. Thank you very much, T. Klausman from Switzerland. Hi to all my Swiss viewers. So let's open this thing up and see what we've got. Doesn't seem to be, seems to be like just one little small thing in here. So, oh no, I've got a note. Hi Dave, I recently had these stickers made and thought they'd fit your open before power on attitude. Tobias from Switzerland, thank you very much. I void warranties. Nice. Excellent. Thank you very much. I void warranties. They are going straight to the pool room. Well, I'll stick them on various things. Awesome. Thank you, Tobias. Lowercase I. Why not? Next up, we've got one from the nether regions. Thank you very much. A Offerman, Idledorp in the nether regions. Awesome. Thank you, Dunke, Mercy, Tak, in all different languages. Let's see what we have here. And ta-da! We've got some sort of little board. Offerman Industries. Adrian Offerman, founder and chief designer. There you go. He's got a PGP key as well if you don't want the powers that be listening in. Nice little QR code there. You can scan that. Fantastic. Link in down below, of course, but you can use your shoe phone to scan the screen if you're that keen. So we have ourselves a little power supply here, 50 volt 2 amp booster enabled, 25 to 54 volts. I presume that's 50 like input, so you could use that for like power over Ethernet or something like that perhaps. What's the output? I don't know. Ooh, look at that. Ooh, look at the mixture of the black and the gold there. That's really groovy, is it not? That looks incredibly sexy. It's got one of those, I can't see it, but that looks for all the world like one of those little off-the-shelf TI jobbies there. So they've added like an external 10-turn or 20-turn trimmer pot there. They've got various output caps there. There are just singular output caps. I've done a video on this. If you want extra redundancy on your caps, just in case they short out, because failure modes for ceramic caps can be a short circuit, and then they can catch on fire. And I've done videos actually showing the release of the magic smoke of these. In fact, I've probably done, I think, 2 videos on this. So if you want the utmost in reliability, like hardly anyone ever does it. But anyway, I'm just letting you know that if you want the utmost in reliability and you want to cater for the failure mode of an individual ceramic capacitor going short and then dumping all the current through and then releasing the magic smoke and catching on fire, etc., you put 2 of them in series, and that basically eliminates that risk there. But like you could say that about every single product that uses every single bypass filtering capacitor on the planet. So nothing specific to this, but I thought I'd just mention that because, I don't know, it just came to mind. Look at that fuse holder. That is sex on a stick. Look at that. Unbelievable. We've got some crimp terminals here. They're not the proper, I prefer the cage clamp type, just personally. In fact, it's probably on the silk screen, and you can probably read that because I can't read that on the camcorder screen here. But I can just read that, enable, 5 volt, ground, stuff like that, so you can do external control. Groovy. Look at that. But I'm liking the look. Design with KiCad. Excellent. Is this open source? Maybe. But I am liking the look of this. It's not quite a gold look because it's not gold. These are not gold-plated traces. These are not gold flash. This is actually solder mask over bare copper, SMOBC. But it looks really nice, doesn't it? That clear solder mask just makes it look like gorgeous. It's almost, brownie copper like. It's just, it is very nice look. I really like that. Like the contrast is absolutely amazing on that. So, you can really see the traces. Great for debugging and stuff like that. So, yeah, I love it. Oh, okay, it's a step-up converter, approximately 12 volts into 32 to 54 volts, adjustable. That's what that big trimmer is. It's one of the created to drive old Soviet VFD displays. Yeah, you could do like lots of, weirder, like older stuff like that, or you could use it for like, power over Ethernet or, like 48 volt systems or anything like that. The Murata components, is that Murata? And the handiwork make it too expensive for large production batches, but this module has found employ in the prototype in 5G ground stations, driving the pulse capacitor of lasers, and in projects of the US Department of Defense. I've included a picture that shows functions of the connectors, so I'll put in the links down below. Yes, it is interesting, definitely more than interesting for the mailbag here, and this will be going straight to the pool room because quite often I'm going to need like a little module power supply for something, and I don't have many. In fact, this might be the only one that can do this sort of voltage range. So that's fantastic. Okay, so it's an 8 to 16 volt input over here. Gone to town on the bypassing. You don't need to actually have, I don't know why all of those are in parallel, by the way. I've done a video on why capacitors are in parallel, and people wanted me to update that video, but I've already actually covered it. Like, I think it's like, I just did this on X the other day. It's like 27 minutes into that video. I explained why often you might want to just replace all the multiple bypass capacitor values, which can be a detriment in some cases, to just one bulk larger value. And I do actually mention that in my video, but for some reason people missed it in the video. Like I was recommending absolutely always put multiple values of capacitors in parallel like this, and that's not always the case. Your mileage may vary. In this particular application here, just powering the input to a DC to DC converter like this, you don't really need like this extra 47 nano jobby here. You know, you might need these 4 10 microfarads in parallel there to get like really low ESR. Is that a polymer? That's probably a polymer electrolytic. You can probably get away, you know, because they've got the ceramic right on the input here. So just, in this particular case, just the polymer electrolytic here is probably enough. But I don't blame Adrian at all, and even like the data sheet for this thing might specify that you might need like, you know, like low ESR ceramics on the input as well. So yeah, anyway, yeah, but you didn't need the extra little 47N down there. It's not really doing anything on its lonesome there. It's probably unhappy. So anyway, I'll link in that bypass capacitor here. God, there's so many bloody things to link in. Anyway, output over here. Oh, it's got a power good signal output as well as an enable signal in. That's a nice touch. Hang on, I've got it hooked up to the electronic load here. I've got no load at the moment, but it's showing 11.5 volts output, 12 volts input, 4.6 milliamp quiescent current there, but why am I getting 11.5? It's supposed to be like 35 volts minimum, isn't it? And is there no, because it's a boost converter. Oh, the enable pin's not on. I think that's what the issue there is. Oh, dole. Should RTFM, I guess. Yeah, that makes sense because this is a boost converter. So it's disabled. So it's not boosting. It's just passing it through, basically, with some loss, with like a diode loss. Yeah, so if I put 1 watt constant load on there, yeah, it's dropped down a bit. If I put 10 watts constant load on there you go. Yeah, it ain't boosting because I haven't got it enabled. Oops, but that's to be expected. So if I enable that with a short-in pin, hello? Nope. So it's not enable to high. It's got to be enable, not enable low. It's not active low. It's because it's a enable pin and a ground pin. I would have thought if you short that out, it enables it. No? And sure enough, if I RTFM, then yes, this module's actually available with an external enable or without an external enable by the looks of it. And yes, it is positive logic input. Unfortunately, with the connector down here, we don't actually have a 5 volt logic enable. So where am I supposed to get that 5 volt logic enable from? That's a huge oversight. Unless I'm missing it, it's not there. But the power good signal does actually have a pull-up resistor, apparently. So I'll connect the... This is really crazy. Connect the enable to the power good. No, you've got to, if you provide an enable signal, you've got to provide some way to strap it or a dip switch on there to like, or a jumper link to like override it or something like that. Anyway, let's now power it on. No, I still can't enable that. Oops, I got the wrong pin. Pebcac. There you go. Enable to power good. Enable to power good. No, we still can't do it. I cannot enable this thing. I need an external 3.3 or 5 volt logic signal to enable this thing in order for it to switch on. Otherwise, it's not going to boost at all. It's just going to pass it through. Oh, okay. I've now got a 5 volt power enable signal going over to there. Have I got on the correct one? Yes, I think so. Let's try it now. Output. Boost. Are we boosting? We're boosting. 54 volts. Winner, winner, chicken dinner. Yeah, just be careful which one you order. So I've got a 10 watt constant power load. That's all happening. Fine and dandy. No problem. I think it's, what is it, 60 watts? So let's take it to 50 watts, shall we? And 50 watts, sure enough, it's doing 50 watts. And if you want to know the efficiency, there you go, 56 watts. So there's 50 watts into the load, 56 watts input. So there must be 6 watts being dissipated in our little converter there. So she's going to get a bit warm. Can we take it up to 60? Nope, it shut off because I've got current limit over here. Oh. There we go. Now we've got 60 watts happening there. So 7.6 watts dissipated in here. So it'll be getting a bit warm-ski. Let me get in the thermal camera. Would have been nice if there were some characteristic curves provided. Of course, the efficiency is going to change with the output voltage and the load as well. So come on, thermal camera. Oh yeah, she's getting a bit hot there. Not sure if you're seeing that. Oh yeah, we're at 100 degrees. That poor little inductor there is 100 degrees. So, yeah, it's not going to be pretty. So, yeah, a bit of heat sink in there would have been nice for, you know, for the full, what is it? Is it rated to 65? Anyway, this is 60 watts output. So, yeah, 103 degrees there. So, yeah, that's a little bit toasty, but that is what I expected. Yeah. Anyway, yeah. Cool, bananas. Just be careful what you order there because you might need a power good signal. Anyway, very cute design. Thank you very much. Link down below. Thank you very much, Michael Covington, and hi to all my viewers in Athens, GA. Is that Georgia? I think in the United States of America. From Covington Innovations. A nice little stickery logo thing there. Got some reused prime package in here. All right, what do we got? Let's have a look. It's a book. It is a book. Oh, and we've got some connectors too. Dear Dave, my grandchildren and I have created the book you would want to have had when you were 8, but using today's technologies, notice how we use Wago connectors to enable young hands to build circuits. Forrest Mims really likes this book. I hope you would too. The big idea is that every experiment teaches a concept, not just put it together and watch the magic. Greetings to all down under. I was at the Messel Science School, Sydney Uni in 1973. Wow. Sydney Uni is really interesting. I've never known a practical industry engineer to come from the University of Sydney. And it's not just me that has noticed this. I'm not sure where all the engineers go when they graduate the engineering department at Sydney of Uni, but it doesn't seem to be in practical industry. So anyway, one of the speakers was Carl Sagan. I'm a bit jealous. Today I'm better known for my other hobby, astronomer, and my profession, AI, but I wrote dozens of construction projects for American electronics magazines in the 1990s. Yes, your name is certainly familiar, Michael Covington. There you go. Does like digital astrophotography stuff. Let's have a look. Electronics experiments for young learners. New approach. They're actual post-it notes. I don't think your book is going to come with the actual post-it notes. I don't think they'd survive. A new approach. Understand every experiment. No unexplained magic. Computer logic, page 55. And the only 6 children. Oh, well, yeah, better get on producing a few more. Available at Amazon. I'll link it in down below. And the parts kits at Jamico. Fantastic. EEyounglearners.com. Wow, this is really something. And there's all the Barrett's. This is very cool. Copyright 2025. So I won't, as usual with books, I will not show you all of it, but let's have a look. What are we going through here? Working with wire. So we're starting out good. No starting out with like, solid state physics and, this is how electrons flow and all this sort of stuff. No, lighting a LED, breaking a circuit, short circuit, 2 LEDs, order doesn't matter, resistors in series parallel. Yes, what conducts electricity? Then you might start talking about, something like that. But you want to get them hooked early by lighting up LEDs. Absolutely. Computing with switches, signaling with switches, a switch made of silicon. Excellent. So you finally get down to, what's a transistor? A sensitive conduction test. And then you get into a real circuit by the looks of it. There you go. I won't read the whole thing, but parts list, what you need: 5-footer hookup wire, some wire cutters and strippers, like some photos, like of typical wire cutters and strippers would have been nice. Oh, no, you buy the kit, don't you? He said like the parts and the kit or something are available. So, yeah, there we go. There's our photo. is. Working with wire, solid wire, stranded wire, safety first. Nice big font. We're talking about insulation, wire strippers. There you go. Wago connectors are the go. I know there's a lot of Wago connector fanboys. I think they're okay. I don't think they're the greatest thing since sliced bread, but, you know, a lot of people love the Wago, so if you're a Wago fanboy, go wild. Wow, this is like really basic. Yeah, I know I said I wouldn't show every page. We've got a resistor, lead. Do we get into Ohm's law? No, we haven't. No, haven't done Ohm's law yet. Haven't done Ohm's law. It doesn't work. They're not talking about resistor values yet. Is that a good or a bad thing? So no mention of like ohms and Ohm's law and stuff like that yet. So I think that's very deliberate. I don't know, leave it in the comments down below. Then we're introducing switches in series. Yeah, I guess you know, who was it who said, it might have been Stephen Hawking, who said that every equation you put in a book halves the audience. So yeah, I think he's probably right. Yeah, it really is like a very practical, like, here's some wires, hook up LEDs and stuff, a switch made of silicon, and now we're getting into like a tip 31 transistor. So that's interesting that you get into transistors. You know, well, it's great, but haven't mentioned like ohms or Ohm's law yet. Here we go. We have not said anything about how electricity is measured. There are two things to measure: how many electrons flow in and right. So, volts, that is abbreviated to volts. Now we're getting into it. And now you get your schematic. Oh, you get the good stuff. Here you go. You get the good stuff now. And that's the end of the book. Oh, I was only getting into it. I was getting right into it. And, oh, I want more, please. But that is excellent. Well done, Michael Covington and kids. That is fantastic. I'll link it in down below. Electronics Experimenters for Young Learners. That is rather cool. I like that. Hats off. Wago connectors. All hail Wago connectors. We're not worthy. We're not worthy. We're not worthy. Will it light up? Place your bets. Place your bets now. Oh, it lights up. Beautiful. And in keeping with our hobbyist prototyping theme here, thank you very much, Busboard Prototype Systems from Calgary in Canada. Hi to all my Canadian viewers. Let's check it out. We've got, you might have a slight spoiler if you read the front there, but let's have a look. We have circuit learning breadboardy kits. Oh, breadboard. Oh, transparent breadboard alert. Transparent breadboard alert. We have a breadboard and prototyping bonanza. Look at this. We've got breadboards. There you go. Look, transparent. Look, it's transparent. Oh, you can get a silvery back on it, but look at that. You can see the connections inside. Oh, isn't that pornographic? Oh, beautiful. Can never have too many breadboards, and we've got just another standard issue breadboard. Again, you can stick that down to any base that you want. Well, it's upside down, all the electrons are going to fall out. Yeah, that's your pretty basic breadboard. It looks like it goes all the way across. It's not split in the middle. Sometimes the top and bottom buses, they actually split in the middle, but that indicates that the solid line indicates that it goes all the way across. Got a BB830 solderless plug-in breadboard. I'll link in all these. It's superior. 830 point plug-in solderless breadboard. Why is it superior? Superior contact precision and reliability. Well, there you go. 21 to 26 AWG and square post headers. Yeah, because like some of the old school breadboards I didn't like, you put in like the square, 0.1 inch headers into them. It would, splay them out too much, and then you couldn't put your little thin resistor leads back in after you did that. So your breadboard holes would get a bit loosey-goosey with that thick 0.1 inch pin action. That's what she said. So you get multiple different sizes and versions there. Excellent. And zip wire 20 centimeter kit. Trust me, you're gonna want to have one of these in your kit. I have like a box with various cables like this. I just used one before actually. We've got pin to pin headers like that, but you've also got female to male like that, and you've also got female to female. So you've got the three different types, and you can peel them off, of course, to use them individually. But yeah, every lab should have like a kit of these. Trust me, they're just incredibly useful for everything, not just for breadboards. Another handy item to have, we've got a breadboard jumper to leads like this, so you can have like plug up external components to the breadboard that might be too thick to plug into the breadboard. Very handy. But wait, we haven't forgotten you matrix board aficionados. This is a snappable PCB breadboard, scored PCB that snaps into 4 smaller boards with 5-hole strip pattern. So there you go. So it's like a mini breadboard. You can snap those into 4 different boards. So I'm actually going to do that so I can actually put those into my drawers, because the drawers, can we? Are they V-scored? Yes, they are V-scored. Look at that. Beautiful. So they're like mini breadboards. Ah, fantastic. There you go. Available from busboard.com, linked down below. And you can see that they're like just the regular like 5-pin strips like you get on your breadboard with the bus over there. Very useful prototyping boards. Love them. They go straight to the pool room. And then we have a solderable breadboard like this. Like that is literally it. Or it's got a bonus strip right across there, and some bonus little toofers in the middle like that. But these are so handy. And if the others weren't long enough, well, you're in for a treat here. Look at this. Bobby Dazzler. And this is just as handy. This is an SMD jobby like this. They're not actually connected, but you can just bridge them with your soldering iron and create little SMD circuits. And you've got a ground plane on the bottom. So it looks like, one of those, each one of those little pads comes up from the ground plane. They're just those little like odd ones in the middle there. So that's fantastic. A double-sided ground plane with solid. I have not seen one exactly like this before. So, wow, that one's also going straight to the pool room. And we have a Blinky Lights kit, juniorgeniuskits.com. It's sealed for our protection. An introduction to the world of electronics using real-world parts. Well, that's as real-world as you get, damn it. Oh, made in Canada. Look at that. Oh, my Canadians go wild. Oh, there you go. Instructions and knowledge guide. Look at this. We've got electricity basics, double lead panel circuits, transistors, capacitors, blinky lights, the decision maker, bistable. Right, so you get all this stuff in the kit. Presumably, look at this. Nice close-up view of how the actual breadboard works. Wow. Somebody's had fun with this. This is excellent. I'm very impressed by the formatting of this. There you go. How to read your resistors, light emitting diodes, capacitors. This is pretty fantastic. A single lead circuit. Look at this. I love the graphics in this. Instructions, things to try. Not going to go through it in huge detail, but this looks top notch. Wow. Double parallel circuit. Then we get to real schematics like this. Then we go from the breadboard thing, and there's troubleshooting procedures as well if it goes wrong. And I hope it goes wrong, because that's for you, because that's when you learn stuff, troubleshooting things. So that is, and try a different transistor. Maybe it got zapped. And what's happening? You get real schematics. Oh, wow, this is top notch. This really is. Look, they've got the switch analogy here. For the NPN transistor, do they mention it's NPN? Do they go into that sort of detail? Not really. Maybe not. But 2 transistor touch switch. This is great. I'm very happy with this. Very impressed. That's their most advanced circuit. The decision maker there. Terrific. Appendix, resistors. Okay, you got the full color code. Engineering units. Excellent. More LED stuff. Exactly what's happening inside the LED there. Oh, LED. For those who don't like me calling it LED. In Australia, it's a LED. Damn it. Leave an argue in the comments down below. Flame away. Go ahead. Math, the creator's toolbox. There you go. Getting into Ohm's law. And look, that's getting quite detailed. I'm liking that. Rules of a series and parallel circuits. Parallel and power calculations and stuff. Wow. And you get a product access code to get additional explanations and detailed answers, including a virtual circuit simulator and stuff. Wow, ski. Okay, I am thoroughly impressed by that. That is one of the best introductory kit thingies I've seen. That is fantastic. I'll link that in down below, juniorgeniuskits.com. breadboard.com. And yes, I do have more mailbag here, but I don't want the mailbags to go to an hour. So thank you to everyone who sent something in today's mailbag. Hope you enjoyed it. If you did, please give it a big thumbs up, and as always, discuss down below. Catch you next time.